Hi, I'm Dave Binns, Application Engineering Manager with Cambridge Engineering, and I wanted to share with you today our TruBTU tool. This web tool can be utilized to calculate the different types of heating efficiencies and effectiveness between different direct fire technologies. You can go in and compare a blow-through, draw-through, or even a recirculation technology and have an exact calculation to how much usable BTU will be available for your project and your customers. To access the TruBTU web tool, go to our website at cambridge-eng.com, and TruBTU is located on the menu tab at the bottom of the list. This will pull up the project information where we're going to input our project name as well as the project location requirements. Enter your city and state, and it will automatically populate the elevation as well as the ASHRAE design temperature for your specific project. We also have the ability to override that if we want to design at a lower temperature. We can also look at different indoor temperature designs. In this case, we'll look at a project that is designed to indoor temperature 70 degrees, which will be used to calculate how much usable BTUs can be available from the direct fire technologies. The TruBTU web tool can compare blow-through, draw-through, as well as recirculating direct fire technologies and how much total BTU is available as well as usable BTUs. You can compare these technologies based on per CFM, total BTUs, or again the net BTUs. In this case, we're going to compare the three technologies based on 10,000 CFM. For each technology, we want to include what are the maximum discharge temperature and temp rises available. With the blow-through technology, we can achieve a 160 degree discharge temperature as well as a 160 degree temp rise. The draw-through technology, because the mechanical components are in the hot air stream, are typically limited from the discharge temperature and temp rise. In this case, because of our bearings and motors in the hot air stream, we're going to limit that technology to 120 degrees discharge. Recirculating direct fire technology, also commonly referred to as 80/20s, can be compared with the TruBTU tool. We have the ability to manipulate how much indoor air will be recirculated, 50%, or in this case, we'll look at the typical 80%. And again, it's going to automatically populate what the equivalent temp rise is available for recirculating direct fire technologies. Once we have inputted all of the specific information for our project, scroll down to the bottom page and click on the Get Results Summary. This will bring us to a new page which will show the exact engineering calculations and thermodynamic principles behind the total BTU calculation. We can compare again the blow-through versus the draw-through or the blow-through versus recirculating. As we saw in the engineering presentation, there's a massive difference from a net BTU standpoint from the blow-through and the draw-through, primarily when it comes to our ability to heat. As we know, net BTU is the most important information from our ability to heat as well as our efficiency and effectiveness of heating large spaces. In the blow-through example, on a 10,000 CFM, again, we have over 1 million BTUs of net BTUs available to heat the space or conductive loads. And on a 10,000 CFM draw-through unit, because of its limited temp rise and because of the air expansion, that technology only has 483 MBH of usable BTUs. Comparing the blow-through versus the recirculating device, the 80/20 system has even less usable BTUs on a 10,000 CFM example. Here, they only have 204 MBH of total heat available to heat conductive loads. When we're ready to share this information, these calculations with our customer, scroll down to the bottom of the page and click on the Share This. What TruBTU is now doing is it's generating all those calculations, all the thermodynamic principles, as well as additional reports to share with our customer and send an email to whoever we choose from the web tool. Here you can input your customer's information, email, first name and last name, as well as your information with a personalized subject line and even message directly to your customer. Click on exactly what reports we want to send. In this case, we want to send the draw-through comparison as well as the full engineering calculations and even a building study comparing draw-through versus blow-through. Click on Send, and it's going to send a personalized email directly to our customer, which we can see here with our personal message as well as links to the report that we wanted to share. click on this link and it's going to open up a new web browser with our site-specific project, design conditions, and full thermodynamic calculations on total BTUs and more specifically net BTUs when we want to compare a blow-through direct fire technology to a draw-through. And as we saw in the engineering presentation, a blow-through design in this example with 10,000 CFM would have 1095 MBH available net BTUs for conductive loads and only 483 net BTUs for the draw-through technology. And when we're talking about energy efficiency and ability to heat, net BTU is the key piece of information that we want our customers to understand when they're comparing these two technologies and fully understand how a BTU is not a BTU. Thank you for your time today. And again, if you have any questions, please contact us or contact your local regional sales manager.